Hey, good morning, everyone. Good morning, everyone. How are you all doing? Good morning, class. Okay, some chatting going on. Okay. Hello, everyone. We are in the class right now. Stop doing that stuff. Good morning. Come. Here itself. Come on. Good morning, everyone. Good morning. And you too have a great day, bacho. But so stop it and focus on the class right now. Come on. Good morning, everyone. Okay, here we go. So we have discussed last time Planck's quantum theory. And right now we are in the middle of somewhere. I'll give you a hint of that stuff. Listen to me carefully. Dekho. Like we are somewhere around the year 1900, and this was a time, before it, electromagnetic wave theory was ruling the roost. It was able to explain almost all phenomena concerning light and energy. According to this theory, basically, that light is continuous, and also, since light is a form of energy, and energy is also continuous, and they are both like what? Wave-like. They both are wave-like, and waves are existing in the continuous form. So this theory claimed to explain that we can explain the interference pattern, the diffraction, the reflection, the refraction, everything they were able to explain properly. Getting it? But in the beginning of the 20th century, there were, like, say, 3 to 4 phenomena which could not be explained properly by the electromagnetic wave theory. These phenomena were black body radiation, photoelectric effect, and spectra of, say, hydrogen atom. And there was one more, and that was heat capacities of solids, with temperature change. Electromagnetic wave theory could not explain all these 4 phenomena. Are you getting it? So we are running as per the timetable, bacho. This is not that I'm running fast or slow kind of thing. Whatever the timetable is given to us, we are going the same way. Here also, the timetable you are given and the physical classes are given. They are running same thing, Harshit. Are you getting that? So it will be better for you people to update yourself. We are all actually in a long-term class right now. Okay? Ashish, Vigneshwar, good morning, bache, good morning. Okay. So the thing is that see, bache, we are in long term. We have to cover the 2-year syllabus in 1 year. In fact, in 6 months. So, and after 6 months, we'll be going for revision. So 6 months, I believe, is not a big time. To complete the syllabus elaborately. So we have to find a way to complete the syllabus in such a fashion that we are able to maximize our score. So for that, you have to update yourself. But so I cannot come down. You have to update yourself up. Getting it? So what we have learned right now, that this electromagnetic wave theory, which assumed that light and energy are continuous or wave-like, they were able to explain the phenomena like interference, diffraction, reflection, and refraction. But they were not able to explain the phenomena like black body radiation, photoelectric effect, spectra of hydrogen atom, and the heat capacity of solid with the changing temperature. They were not able to explain that. So when your theory is not able to explain the experiment, it's time that the theory should be updated or should be thrown away. It was time for both. Are you getting it? So we are into the quantum mechanical theory, which will be explaining all these three phenomena one by one. Getting it? Chalo, aado. So, we have discussed in the last lecture that Planck was able to explain the black body radiation, and today we'll be understanding what is actually black body radiation. So come on, stay with me. So first one is black body radiation. Please write down black body radiation. And bacho, what is black body radiation? Or say, what is a black body? What is a black body? Black body is any body, is an idle body. Please write down. Black body is an idle body which can emit and absorb, which can emit or absorb all radiations, which can emit or absorb all radiations. Which radiations? Electromagnetic radiation. Are you getting it? That means if there is a black body, it can emit all kind of radiations and it can absorb as well all kind of radiation. These radiations may range from, like say, cosmic, gamma, X-rays, UV rays, visible rays, infrared rays, microwaves and radio waves, all of them. It can emit as well as absorb all kind of radiation. This is an idle body and this does not exist in this world. So what we'll do, we will take an approximate example of a black body. So any hot glowing body can be approximately taken as an example of black body. So let me take an example. Say if I take a piece of iron, and I start heating it, and keep on increasing temperature, and you will notice that this iron object start glowing red. This will glow red in color. Yes or no? Have you seen that stuff? And if I increase the temperature a little bit more, you will observe that this becomes orange in color. And after that, if I further increase, you will also notice, you can see these videos on what do you call that? YouTube also. So it will become yellow. But if I heat it further, if I heat the body further or increase temperature, you will see that this becomes actually white in color. And if I increase it further, if I increase the temperature further, I'll find that this becomes blue in color. This will be glowing blue in color. Very good, Vinay. Very, very good. Preeti, very good. That's great. Yes or no? Are you getting it? Now understand one thing before I explain that stuff. This is very, very important. This is the only thing which is important in the black body radiation as far as NEET is concerned. See that stuff? We all know that if I increase temperature, energy will increase. Yes or no? Will you agree? If I increase temperature, energy will increase. Yes or no, boys and girls? Come on, be quick. I also know that E is equal to H nu is equal to Hc upon lambda from the last lecture. We know that stuff. Can I say E is proportional to frequency, proportional to 1 upon lambda? Which also means that energy will increase if frequency will increase, and that means lambda will decrease. Or I can say that energy will decrease if frequency decreases and lambda increases. Great. It's very important and very simple also. Be here, be focused. So can I say that if temperature is higher, energy will be higher, and if energy is higher, frequency will be higher. Frequency higher also means lambda will be lower. Similarly, if temperature is lower, energy will be lower, frequency will be lower, but lambda will be higher. We can draw this thing from here. Yes or no, everyone? And from here, I mean, if you look out over here, if I talk about Vibgyor, say Vibgyor, understand it, everyone. Please be focused over here. It's extremely important. If you understand one thing, I'll say, in last lecture we have understood that all electromagnetic radiation, including gamma, UV rays, X-rays, infrared, radio waves, all of them, they are all because of what? Vibration. Because of what? Vibration of charged particles. Vibration of charged particles. Agree or not? They're all because of vibration of charged particles. Hello? That means if temperature is higher, energy of the particle is higher, and that charged particle will have higher frequency. It will vibrate more. More temperature. तो भाई इधर focus करना यार. This 143 LV, or I'll delete you from this class. Focus here. Who got the marks or not, this is not none of your purview. What we need is basically that you are getting how many and how we'll increase that. The temperature increase, energy. देखो बच्चे इसका नाम जो भी है यार. See, you are here in this class in the long term. The primary reason for that you are not focusing on the studies. You are interested in all this useless stuff going around. You look too much outside. You are concerned about what others are doing, and you are not considered what you should be doing. You should be focusing out here. इधर देखना यार. Selection यहाँ से हो रहा है. ये बकवास करना थोड़ी ना होना selection तेरा. Temperature higher, energy higher, that frequency of vibration will be higher. More the frequency also means that lambda will be lower. Yes or no? Yes or no? Great. Now look over here. So what I'm saying, if you look at that, if temperature is higher, then out of Vibgyor, who will have higher frequency? Out of Vibgyor, who will have higher frequency? We know that as we move from left to right, the frequency decrease and lambda increase. So this violet or say blue, or say violet, indigo, blue are the three shades of a same color almost. That means this violet or say blue, you can say one and same thing. This will have higher frequency, which means lower lambda, which means what, boys? Energy will be higher when the temperature is higher. If temperature is higher, the charged particle will vibrate more. More vibration will be there. It will emit a photon of higher frequency. More vibration, more frequency. It will emit a photon of higher frequency. Yes or no? And at lower temperature, you will see that if temperature is lower, energy is lower, the frequency of vibration will be lower, and if frequency is lower, wavelength will be higher, and you will see which color? Red color. You will see red color. So can you understand that, boys now and girls, that at lower temperature, which color you will observe? Red color. And at higher temperature, which color you will observe? Violet, indigo, blue kind of thing. Yes or no? Yes or no? Okay, you can take a screenshot and you can later on write it down. I'll move forward. Okay, now see that. Understand this also. Okay, wait, come over here, beta, come here. Now see, suppose that some hot glowing body is appearing red in color. So will you agree with me if I say that this red color object or red hot glowing object, can it emit bachcho blue color? Can it emit blue color photons or green color photons? Or maybe ultraviolet or maybe infrared? Is it possible? Is it possible? Actually, it is possible, bachcho. It is possible. Listen to me now. That's what I'm saying. Please pay focus. This is not that easy. You are understanding, Please be focused. It can. No. At the same temperature. I'm saying. Understand. When you see something red in color, it is never perfectly red. I'm saying that out of, say, all the radiation, maybe 90% radiations are red in color. 90% radiations are red in color. But But beta, it is also possible that 1% of the light emitted is maybe beta green in color, maybe 0.1% is blue in color. Are you getting it? Maybe like say a 2.1% is infrared beta, and maybe 0.001% is say X-rays beta. It is also possible that maybe 0.01 is say gamma rays beta. I mean, are you getting or not? So all these are the possibilities. I told you that any hot glowing body can be approximately told as what? A black body. What is a black body? Which can emit and absorb all possible radiations. All possible radiation. But since most of the radiations, most of the photons are red in color, this glowing body will appear predominantly red in color. It will be emitting blue, but it will be overshadowed by the red color photons. Yes or no? Yes or no, Sharanya? I mean, it can absorb also. I mean, if I fire a blue light, it will absorb. If I fire a gamma ray, it will absorb. It can absorb also. No problem with that. No problem, beta. Yes or no? Now, understand one thing. When I say something is blue in color, something is blue in color, it's a hot glowing body, blue in color. Is it correct to say that this can emit like say red color also? I mean infrared also, microwaves also, radio waves, gamma rays, all of that is possible or not? It is possible. But predominantly maybe 89% will be blue in color, maybe 1% will be red in color, maybe 0.01% green in color, maybe 0.01% violet in color, maybe 0.001% maybe X-ray or gamma ray, whatever it is like. But there will be lesser in color. Predominantly, it will be having blue color. Yes or no? So here we call the predominant wavelength of this red will be called lambda max. Lambda max. What is the meaning of lambda max? That maximum particles in this body are vibrating in the range of red color. Maximum particles are vibrating in the range of red color. And here the lambda max will be called, boys and girls, blue. Because over here in this body at a given temperature, maximum particles are vibrating at blue range frequency or lambda. Yes or no, Gudiya? Everyone? Are you getting that or not? Understand first, then marks will come automatically. You simply need to understand that first. Okay, very good. Okay, and suppose a hot glowing body is appearing orange in color. So lambda max will be what? Orange. Lambda max will belong to what? Orange color. Sure about it? जल्दी करो यार बच्चों, बहुत स्लो कर रहे हो. Okay, good, very good. चलो ठीक है. Now in NCERT there is a graph. That graph is that say this is intensity and we have got lambda out here. Lambda. Okay. So as you keep on moving from left to right, lambda will keep on increasing. Okay. Now you see that at a given temperature, I am saying that this body is glowing red in color. So the graph, it is found that it is something like this. Say at 5000 Kelvin, I am saying that this means maximum number of particles are going to show you what? I max, intensity maximum. At what? This will be called lambda maximum. This will be red in color. Okay, Sharanya. Okay, no problem. Look over here. Now see that at 5000 Kelvin, I am saying that this body is appearing red in color, which means what? Most of the particles are giving red color wavelength. So you can see that maximum intensity is of what? Red color. Maximum particles are giving red color. Yes or no? Okay. And I am saying that yes, this wavelength suppose is of infrared. So some particles are there of infrared also. Some are for microwave. Some are for radio waves also. But as compared to red, they are comparatively less. I am saying that over here, this lambda, lower lambda is of suppose say blue color. Thus blue color is there. but predominantly we see what? Red color photons. Yes or no? Are you getting it or not? Good one, very good. Now, I want to draw the same graph at say 7000 Kelvin. At say 7000 Kelvin. So what do you believe? The graph will be like what? Like, see, first case like this or second case something like this. Which case? Which case? First is like this. First is like this and second is like this. Which color? Second. Very good. Very good. No, not first. Second will be there, beta. Arey, bachcho, kya kar rahe ho? See that. See. As the temperature increases, I told you energy will increase. Energy will increase. That means what? Frequency will increase, but lambda will decrease. And on this graph, lambda decrease will be this way. Lambda will decrease this way. So your lambda max will also decrease. Are you getting it or not? So over here at 7000 Kelvin, the maximum number of photons, you can see this one. This will be lambda max for 7000 Kelvin. How much, beta? This will for blue color. This will be for blue color. So lambda max is decreasing. As I increase temperature, lambda will be decreasing. So most of the particles will be showing blue color and intensity maximum will be of blue color range. Yes or no? Come on. Yes. Have you understood this graph or not? Intensity. Good one. So chalo, can I ask you one question? I mean, look over here, look over there. See that. Say, I'm saying, say, we have got 4000 Kelvin, 3000 Kelvin, and say 7000 or say 8000 Kelvin. Suppose say, na? These are temperatures I'm in. So I believe the graph will be for 3000 something like this. For 4000, sorry, beta, sorry. For 4000 something like this, and for 8000 something like this. Agree or not? So suppose this one lambda max is of red color, and this suppose lambda max is of say green color, and this lambda max will be suppose of say blue color. Will you agree or not? Will you agree or not? That means higher the temperature, maximum particles will shift towards blue color vibrations. They will vibrate more, and more vibration means we are going to get a light of higher frequency. Agree or not? Come on. Okay. That's good. So they will ask you that graph. Very well understood. Very good. Now see this thing. Like if we plot a graph, high wavelength means less temperature. Very good. So I mean, sorry, beta, coming over here again. Can we say properly, beta? Can we say properly over here that as the lambda is increasing for a given temperature, say I'm taking say at 5000 Kelvin. Say at 5000 Kelvin, can you see that as lambda increases, intensity also increases. Agree or not? As lambda increases, intensity also increases. But if lambda is more than lambda max, once I come ahead of the lambda max, the intensity keeps on decreasing. Yes or no? It will first increase and then decrease. With increase in lambda, it will increase till this point. Which point? Lambda max. And after that, it will decrease. So if lambda is more than lambda max, intensity will keep on decreasing. Yes or no? Everyone? Great. Very good. Now see what I'm saying. Can I say now few things? Tell me true or false. Tell me true or false. That the color of the body will depend on temperature. True or false? The color of the body will depend on temperature. Yes or not? Yeah, it is true. We know that stuff. Now color depends on temperature, and we also know that the color of any object will depend on the frequency of vibration. Will depend on the frequency of vibration. Vibration of charged particles. So color depends on vibration of charged particle, and vibration of charged particle depends on temperature. So temperature can change the color of the object. Can change the color of the object. And as you can see over here, so this is a graph, a particular graph. This point is, boys and girls, lambda maximum, and over here, if lambda increases, lambda is increasing, but lambda is less than lambda max. Over here, lambda is increasing, so intensity is also increasing. Intensity is also increasing. But after this point, if lambda increases, that means if lambda is more than lambda max, over here this is lambda max, and here lambda is less than lambda max, but here lambda is more than lambda max. So after this thing, if I keep on increasing lambda, the intensity keeps on decreasing. Intensity keeps on decreasing. So over here in this graph, what I'm trying to tell you is that intensity will increase up to what? Lambda max. But after that, intensity keeps on decreasing. Yes or no, beta? Someone was asking to repeat it again. Have you understood that stuff? One Gudiya was not able to explain. Understand that. Are you understanding now? Okay, very good. Okay, now one more thing. So as I keep on increasing temperature, lambda max keeps on decreasing. Yes or no, beta? At 5000 Kelvin, this was red, and at 7000 Kelvin, it was blue. Yes or no? That means lambda has decreased. Yes or no, Gudiya? Everyone? Very good. Okay, now this part is done. Okay, now let's come to photoelectric effect. Go through NCERT once. Go through NCERT once and let me know that if there is some problem you are having. I don't think that you will be having any problem now. Come on now. So please come to photoelectric effect. Please come to photoelectric effect. It's very, very important. Come on, everyone, be quick. Be very quick. Photoelectric effect. So what happens out here, understand. Let's draw the diagram first of all. We'll understand something like this thing, and we have got a metal cathode attached to a battery kind of thing, and there is an anode. This is anode, and anode is always positively charged, and here this is metal cathode. This is metal cathode, and it will be negatively charged, and this is negative positive. Now what happens? But before I go on to explain something, since you people have done it already, that if a light is incident on this metal, and if the incoming light is having a sufficient frequency, sufficient energy, it will eject electrons. This will eject electrons. These electrons are called photoelectrons. The electrons ejected because of the incoming photons will be called photoelectrons, and they will reach there. These electrons will reach there, and this will complete the circuit. And if I have got an electrometer, it will show a deflection. Yes or no? This is called photoelectric current, or it's called photoelectric circuit. With this photoelectric circuit, this photoelectric circuit is used where? In photovoltaic cell. So they ask you one question, that which metal is best suited for photoelectric effect? Like they'll give you lithium, sodium, potassium, rubidium, and cesium. Which will show highest tendency to show photoelectric effect? Come on, everyone. Very good. This will be the order of photoelectric effect observed basically, na? And technically speaking, these three are the metals which are normally used in photoelectric effect, with cesium being the best one. Cesium being the best one. The reason is that as you go down the group, what happens? Ionization energy keeps on decreasing, and it becomes easier to eject the electron if the IE is lesser. This IE is also called beta phi, which is called work function, also called work function. Work function, also called threshold frequency or threshold energy, also called, or H nu naught. Just write down, I'll explain that. Just write down, na? Very good. H nu naught or what? Threshold energy. Threshold energy. Threshold energy. Now understand one thing, that this phi is nothing but H nu naught only. Work function is nothing but threshold energy only. Very good, bache. Very, very good. So as you keep on going down the group, the work function or the threshold energy decreases, and it is because what? Ionization energy is also decreasing. Amount of energy required to take out electron is decreasing. Is that clear to all of you? Be quick. Okay. Now again, the prevalent theory at that time was electromagnetic wave theory, and I told you that electromagnetic wave theory could not explain photoelectric effect also. So there are few things they were not able to explain. First write down, then I'll explain all of them. Okay, done? Chalo, write down. So please write down, electromagnetic wave theory could not explain. Electromagnetic wave theory could not explain. First point, time lag. Now what is time lag? I'll explain. Just write down. Second, it could not explain threshold frequency that is called nu naught, or threshold energy that is nothing but H nu naught, which is nothing but what? Work function called phi. They could not explain this thing. So these 2 points couldn't be explained by electromagnetic wave theory. Now came the greatest hero of the 20th century, and his name was Einstein. To explain photoelectric effect, Einstein will explain photoelectric effect and will win the Nobel Prize also for that. Getting it? So please write down, according to Einstein, light is made up of photons. Light is made up of photons, hai na? So when I say they are made up of photons, it also means that light is what? Particle like. Light is what? Particle like, hai na? It will travel in the form of packets, hai na? And not in the form of the continuous waves, which was the thesis of what? Electromagnetic wave theory. Second, very, very important. So Einstein proposed basically that one photon interacts with one electron at a time. One photon interacts with one electron at a time. Very, very important, na? These 2 points will make everything clear now. Everything very clear. One photon interacts with one electron at a time. Okay? And he also said that, third point, if the frequency of the incoming photon is more than the threshold frequency or the h nu energy of photon is more than threshold energy. If this is the case, electron comes out immediately. Electron comes out immediately. Which electron? Photoelectron. The photoelectron comes out immediately. Second, if frequency of incoming photon is equal to threshold frequency, or the energy of the photon is equal to threshold energy, in that case, what will happen? In that case, kinetic energy of electron is actually equal to 0, which means what? The electron will just come outside and will stick on the surface, but will not leave the metal. It will just come outside. Yes or no? Since it doesn't have any kinetic energy, it cannot leave the metal as such. Is that clear? Third one, if the frequency of the photon is less than the threshold frequency, or you can say that h nu, the incoming photon has a lesser energy than the threshold energy. In that case, what will happen? No photoelectric effect will be observed. No ejection. No photoelectric effect will be observed. Are you getting that? Okay, now next point, please write down, very, very important, that kinetic energy of electron ejected is proportional to the frequency of the photon. If the frequency of photon is higher, the kinetic energy of the electron is also higher. Getting it? Okay. And now this is when nu is more than nu naught. Nu is the frequency of the incoming photon, and this is the threshold frequency. Okay. Next point, that kinetic energy of electron is independent of number of incoming photons. And this number of incoming photons, boys, is also called intensity of photons. Intensity of photons or light. Intensity of photons, or you can say intensity of light. Kinetic energy does not depend on the intensity of photons or intensity of light. I'll explain that, don't worry, but right now keep writing. So if I ask you to plot a graph, that this is kinetic energy of electrons and this is the intensity of photon. The graph will be straight line, parallel to x-axis. It will remain same, it will not change. Getting it? I'll explain that. Just first write down the notes. So because once you have the notes, you are safer now and we can do the explanation kind of thing. Getting it? Chalo, come on. Okay, here we go. Also, one more point, and it says that number of photoelectrons coming out is proportional to intensity of photon. Intensity of photons means what? Light. Intensity of photons are nothing but light. That means what? More photoelectrons will come outside if intensity of photons is more. Yes or no? And this will happen when? If the frequency of photon is more than that of threshold frequency, only then. If, okay? Otherwise, the electrons will not come out. And the graph, I believe, boys, will be something like this. Number of photoelectrons, and this is what? Intensity of the light. It will be a straight line. Getting it? So more the photons, more the electrons coming up. 10 photons, 10 electrons will come outside. 20 photons, 20 electrons will come outside. Yes or no? So 10 photons, 10 photons, 10 electrons will come outside. 20 photons, 20 electrons will come. 30 photons, 30 electrons will come. Yes or no? They are directly proportional. Yes or no? Yes or no? Come on, be quick. Good, very good. Very good. Now, I will explain whatever I have told you right now. Okay, come on. I'll explain that stuff. See that, suppose we are having an example. This is a metal, and the metal is having a work function also called threshold energy, or suppose 2 electron volt. Suppose say 2 electron volt. Now, I'm saying the incoming photon is of 5 electron volt. How much energy? 5 electron volt. Now, if it is striking over there, the electrons will be ejected. Yes or no? Electrons will be ejected. Now, what is the kinetic energy? Maximum kinetic energy of this electron being ejected. How much? Come on, everyone, be quick. Be quick. Threshold is 2 electron volt. Incoming photon is of energy, say 5 electron volt. Everyone, come on. So 2 electron will be required to pull the electron outside the surface, and rest will be given what? Kinetic energy, and that will be 3 electron volt. We know that one photon can interact with 1 photon at a time, 1 electron at a time. 1 photon can interact with 1 electron at a time. Okay. Now, sorry. Let's take one more case. One more case. And right now, I am increasing the number of photons. I am increasing the number of photons, and when I increase number of photons, that means I have increased the intensity. I have increased the intensity. So 5 electron volt, 5 electron volt, 5 electron volt. Yes or no? And they will be incident over here, and each will interact with 1 electron. Each will interact with 1 electron, with having what? All of them having the same work function. How much? 2 electron volt. Each having 2 electron volt. So each will come outside. Each will come outside with how much kinetic energy? The maximum kinetic energy will be how much? 3 electron volt each. 3 electron volt each. Yes or no? Yes or no? That is good. That means if I increase the intensity, the number of photoelectrons coming will increase. 1 photon, 1 electron, 3 photons, 3 electrons will come outside. 10 photons, 10 electrons. And that was the meaning of this graph. That more the photons, more the electrons. Yes or no? Yes or no? When the energy of the photon is more than the threshold energy. Yes or no? Yes or no? But you can see that only the number of electrons coming outside is increasing, but kinetic energy remains same. Kinetic energy does not depend on the intensity of photons. Is that clear to all of you? Come on. But if I have got like say second case, same metal, and incoming photon is of say beta 1 electron volt, and phi is given as 2 electron volt. Yes or no? Now, if I assume wrongly, the way the people of electromagnetic wave theory were assuming, they were assuming that maybe the light which is coming is going to come with the energy of 1 electron volt per second. 1 electron volt per second. Then it will keep on, this electron will keep on absorbing the energy, and suppose say it absorbs the energy for 3 seconds. In 3 seconds, it will absorb 3 electron volt and will come outside with what? Kinetic energy of what? 1 electron volt. But after how many seconds? After 3 seconds. After 3 seconds. But when experiment was done, they found that no electron was coming. How much you wait, no electron was coming. So according to Einstein, and he was correct, because experimentally we were getting the electron immediately without any time lag. So when I say time lag, it means delay. Time lag means delay. According to the electromagnetic wave theory, electrons will take some time to come outside. While the fact was that either they will come out immediately or they will never ever come out. Yes or no? So Einstein was able to explain that why there is no time lag. Yes or no? He said that if the incoming energy is more than the threshold energy, electrons comes out immediately. It won't even wait for that. He also said that one photon will interact with one electron at a time. There is no chance that an electron can absorb 3 or 4 photons. No, this is not going to happen. Yes or no? Yes or no? Now one more thing, that again the same metal, so this photon is of 5 electron volt and phi is say 2 electron volt. This electron will come outside with say kinetic energy equal to what? 3 electron volt. Now suppose say if I have got say a photon of say 10 electron volt, it will come outside with the kinetic energy of, bolo bachcho, 8 electron volt. Yes or no? So if the energy of the incoming photon is higher, only then the kinetic energy will be higher. So I told you one point that kinetic energy of the electron is proportional to what? The energy of the photon. More is the energy of the photon, more is the kinetic energy. Yes or no? Yes or no, everyone? Now tell you one thing. Few questions I'm asking, tell me true or false. Tell me true or false, है ना? That kinetic energy depends on number of photons. Number of photons. True or false? Kinetic energy depends on number of photons. Oh, नहीं, false. That is false. Kinetic energy does not depend on number of photons. Only number of electrons. Oh, see that. This is intensity of photon. Intensity means number of photons. Number of photons. And this is number of photoelectrons. Photoelectrons. This graph is like this. But kinetic energy, and this is what? Number of photons. Number of photons also means intensity of photons. This is same. It does not depend on that. Boys and girls, अब तुम सो रहे हो यार, you're sleeping. Tell you one thing now, that kinetic energy will increase if the the energy of the photon increases. True or false? Kinetic energy of the electron will increase if the energy of the photon increases. This is true. This is true. Yes, this is true. Good one. Now let's see that. Boys and girls, tell me one thing. In the examples we have done, if I have energy of photon as 5 electron volt and 2 electron volt is the phi, then 3 electron volt becomes what? The kinetic energy. This is called conservation of energy. This is called conservation of energy. So can I say this is what? H nu, the energy of the photon, and this is what? Phi, and this will be called kinetic energy. Yes or no? This is nothing but H nu equal to H nu naught plus kinetic energy, because they are one and same thing. Achha, there is a question. He's saying that, sir, if E is equal to NH nu, then they are depending. Wait. What he's saying? He's saying that, sir, E is equal to NH nu. Then the number of photons. Beta, see, you are telling me something different. What I'm saying is that if number of photons coming are more, then the energy of these photons will be more. Energy of the photons will be more. This is total energy. But these all photons cannot interact with single electron. One photon will interact with one photon. Yes or no? That means if, like, say, 4 photons are coming. Yes or no? So here the energy of the 4 photons total is higher, but each photon will interact with one electron. So this is 5 electron volt, 5 and 5. This becomes 20 electron volt now for 4 photons, but each will emit only one electron. each will emit 1 electron of kinetic energy. If the pi is say 2 electron volt, each will be having 3 electron volt as kinetic energy. Chilling guy, is that clear? Total energy is higher, no doubt about it. But since each photon will interact with 1 electron only, beta, so kinetic energy will be same. Only number of particles, number of electrons coming outside will be more. Chilling guy, oh bhai, chilling guy, jaldi bole yaar. Okay, good. It depends. Kinetic energy depends only on frequency. This frequency. Frequency means energy. Okay, boys, come on. आओ इधर आ जाओ. हम कहाँ थे? This one. So this was the case, है ना? This is the case. So can I rewrite this thing, boys and girls? That this will be kinetic energy is equal to h nu minus h nu naught, and this can be written as y equal to mx plus c, where slope is what, beta? The Planck's constant. Planck's constant. So this is the equation of a straight line, which I can draw very well. See that stuff? This is kinetic energy on the y-axis, and on the x-axis I've taken the frequency. So this will be a straight line. Slope is positive. Slope is positive. Yes or no? And the intercept is what? Negative. So it will be joining out here. Minus of h nu naught. And look up over here. If I make nu equal to nu naught, if I make nu equal to nu naught, then that means what? This will also become h nu naught minus h naught equal to what? 0. It will become 0. The kinetic energy will become 0. So at this point, when nu is equal to nu naught, kinetic energy is 0. That means electron will be coming only when? Electron will be coming only when this nu is more than the nu naught. And before that, nothing will happen. No kinetic energy. And the slope is what? Slope is Planck's constant. Slope is Planck's constant. So they will ask you 3 graphs, hai na? I have explained all the 3 graphs. You should note it down now. Note down, be quick. Everyone be quick. Done? Okay, come. Now come. See that. X-axis. But this is frequency. And here the frequency is equal to nu naught. Okay? Amina, is that okay? Okay, good. Very good. Okay, now what I'm saying. Now, there is one thing you should understand to solve the questions. It's very, very important that boys and girls understand that the photons are striking and the electrons are coming outside, which say kinetic energy equal to 3 electron volt. Hai na? What I'm saying that this electron is negatively charged, and somehow I apply a negative a plate over here. A negative plate over here. So, it will have basically what? An effect of pushing the electron over there. Yes or no? If I'm saying, if I apply an opposing voltage of say EV naught equal to say 1 electron volt. How much, beta? 1 electron volt. 1 electron volt. Then the electron will be coming outside with how much of energy? Initially, it was coming with the energy of 3 electron volt. Now I'm pushing it, opposing it with 1 electron volt. It will now come with what? How much of energy? 2 electron volt. It will come outside with 2 electron volt. Now suppose if I oppose, it would say 2 electron volt. If I oppose it with 2 electron volt, what will happen? It will now come with what? 1 electron volt. And if I apply 3 electron volt, now what will happen? What will happen? It will not come outside, it will just come and will stick on the surface. Yes or no? Now this 3 electron volt is what? The kinetic energy earlier. Yes or no? This 3 electron volt, which is the kinetic energy, is also called, if you are applying the same energy to stop it, is called stopping potential. Is called stopping potential. Please note it down. Sometimes in the question, they will not give you the kinetic energy. They will give you the value of stopping potential, which is nothing but the kinetic energy of the electron. Are you getting it? So what is the stopping potential? It is the minimum energy required to stop the electron from being ejected. Minimum energy required. So suppose if I apply 5 electron volt, will the electron come out? No chance. 20 electron volt, will electron come out? No chance. But the minimum energy required to stop the ejection of electron is what? 3 electron volt. This minimum energy required to stop the ejection of electron is called stopping potential. Is called stopping potential. It has a value in the numericals, which we will do probably next time. Are you getting it? We'll do the numericals next time, and you will feel that we have understood that stuff. So I'll give you in a question the value of stopping potential. You have to make sure that you're writing it with what? Kinetic energy. So here we can also write down again, beta, that this kinetic energy is nothing but EV naught. EV naught equal to what? H nu minus H nu naught. Remember that? This is stopping potential. That is the important part. Kinetic energy is nothing but stopping potential, or the value of potential, stopping potential is kinetic energy. So if I say the stopping potential is 8 electron volt, if I say stopping potential is 8 electron volt, what was the value of kinetic energy? The value of kinetic energy, come on. Eight electron volt. Very good. Very, very good. Perfectly done. Now, see, tell you one thing. If I have to plot a graph, there's no point in that stuff. Now, see that what I'm saying. Let's do 2 questions and then we'll leave. We'll do the numericals later on. Enough. So what I'm saying, first question, that in which case kinetic energy of photoelectron is maximum. First, red color. Second, green color. Third, infrared rays. Fourth, blue color. In which case you believe the kinetic energy of electron will be more. Kinetic energy, remember that kinetic energy is proportional to frequency of the photon. More the frequency, more the kinetic energy. Answer is blue. Very good. Very, very good. Answer is blue. Very good. Brilliant answer. Keep it up. Okay, one more thing. One more question I'm asking you. This question is that if threshold frequency, nu naught, if threshold frequency is corresponding to green color, then photoelectric effect is observed in which case? In case of, say, violet light, second yellow, third red, and fourth one infrared. Come on. In which case, if the threshold frequency is for green color, in which case the photoelectric effect will be observed. It will be observed in violet case, because in the Vibgyor, remember that. So this is the nu naught. Photoelectric effect will be observed only when nu is more than nu naught. That means in violet, indigo and blue, it will be observed. But if the nu is less than nu naught, like this one, no photoelectric effect will be observed. Yes or no, everyone? Got it, understood or not? Okay, now what we'll do, we will do the questions in the next turn. Till then, see that. You want to get it explained? Pravina, what I am saying, beta, understand that threshold frequency, the minimum frequency required to eject the electron is green color. Is basically, beta, what? Green color. You tell me that in the Vibgyor, this is nu naught. This is nu naught. Now, to have electron ejected, the energy of the photon should be more than the threshold energy. Yes or no? This threshold energy will be h nu naught. I believe that I need h nu to be more than h nu naught. Only then photoelectric effect will be observed. But if h nu is less than h nu naught, I mean this side, no photoelectric effect will be observed. And I know that the frequency of yellow, orange and red is less than, this is nu naught, and this frequency is less than green color. Pravina, understood? And violet, indigo and blue, their frequency is more than the threshold frequency. So more is the frequency, more is the energy, because we know that to observe a photoelectric effect, the nu should be more than nu naught, or you can say h nu should be more than h nu naught. Otherwise, there will be no photoelectric effect. Got it or not, Gudiya? Okay. We'll do the question, bachcho, next time. Okay. Till then, keep on revising. Okay. Chalo, bye bye, bachcho. All the best. God bless you all. Have a great day ahead. Bye bye.